Hello everyone, myself Gauri Sonone from KK Wag Arts, Commerce Science and Computer Science College, Bhavsaheb Nagar, Pimplas, Ramachi. Today's, today's I can explain you kinetics, the rate of mechanism of a chemical reaction. In this topic, we are going to study about chemical kinetics, reaction of the rate or rate of reaction, factors influence reaction rate and units. Next topic, kinetics, the rate and mechanism of the chemical reaction. Firstly, the factors that influence reaction rate, expressing the reaction rate. Third is the rate law and its component. Fourth is integrated rate law. This is the concentration changes over time. Next one, reaction and mechanism. The steps are in overall reaction. And last one topic is catalysis sending of a chemical reaction. Now, chemical kinetics. Chemical kinetics means the study of reaction rate, the changes in concentration of reaction or product as a function of time. There are two relationships. First one, qualitative relationship through the derivation of the rate law, and second is kinetics can reveal much about the mechanism of a reaction. Next is the reaction rate, the central focus of the chemical reaction. Let us see the first reaction. First one is the reactant to give the product in this diagrammatically. Next, factors influencing reaction rate. First is the reactant concentration. Molecular collision are required for reaction to occurs. Therefore, the reaction rate is directly proportional to the collision frequency and the concentration. Physical state. Molecules must mix to collide. When reactants are in different phases, the mole finally divided a solid or liquid reactant. The greater the surface area per unit volume, the more contact it makes with other reactant and the faster the reaction. Next is the temperature or next factor for the temperature of the chemical reaction. Molecule must collide with sufficient energy to react. Firstly, the higher temperature translates into the more collision per unit time and into the higher energy collision. Next, collision energy and reaction rate. The other factors for the collision. The reaction of the trajectory. Not all collisions with sufficient energy are produced. The diagrammatically collision energy of reaction rate for O3, this is the ozone plus NO, nitric oxide, to give O2 plus NO2. Therefore, the energy collision leads to product. And last one is the no reaction for the more collisions. Expressing reaction rate. The reaction rate means the changes in reactant or product per unit time. Reactant decreases, product also increases. In general reaction, A is the reactant to give the B, B is the product. Measure A1 and T1, the measure of the A2 and T2. The average rate of reaction is minus A2 minus A1 divided by T2 minus T1. T means temperature. The rate is always expressed in a positive value. Therefore, my negative sign is cancel. The minus delta A divided by delta T. This is for the delta A is equal to A2 minus A1 and delta T means T2 minus T1. Okay. Rate units is equal to moles per liter per second. Okay. Also reaction rate is equal to is always expressed in positive, therefore positive delta B divided by delta T. Expressing the rate in terms of changes in reactant and product, reaction for the reactant and product to give H2 in gas plus L2 in gas to give twice HI. This is the gases. The rate of reaction is concentration of the reactant is H2 divided by delta T is equal to productचा concentration. The delta I2 divided by delta T is equal to half of delta of HI divided by delta T. This is the expressing or changes the rate of reaction. The mathematics expression for the rate in a numerical value of the rate depends on the substance chosen in the interference in a reference. For the general reaction, small a capital A plus small b capital B to Q small c capital C plus small d capital D. Therefore, the rate of reaction is minus 1 by A delta A upon delta T is equal to minus of 1 by B delta of concentration of B divided by delta T is equal to 1 by C delta of C concentration of C divided by delta T is equal to 1 upon D delta of the concentration of D divided by delta T. This is the general reaction and the rate of reaction. Firstly, the reactant concentration and second is the product concentration. Next topic is how is the rate law determined experimentally. The procedure: first, measure initial rate, therefore in bracket from concentration measurement. Second, use initial rate from several experiments to find the reaction order. Third is the calculate the rate constant. This is the rate law determined experimentally. Next is the rate order terminology. The first one is there are three types. First is the first order reaction, second order reaction, third order reaction and zero order reaction. This is the order of terminology. First one is the rate is equal to K. K is constant and concentration of A. This is the first order reaction. Rate is directly proportional to the reactant of the A or concentration of the A. Therefore, first order reaction only one reactant are used. Second is the rate is equal to K concentration of the A square. There are the second order. Overall, the rate is directly proportional of concentration of the A square. This is the reactants are 2. That for the second order reaction. And next is the rate is equal to K concentration of A is zero order. The K is equal to 1 and the zero order reaction rate independent of the concentration of the reactant. For example, in the order of terminology, first one is the NO in gases plus O2 in gases to give NO2 plus O2. The rate is equal to concentration of the only reactant. The reactant is NO and O3. This is the two reactant, therefore second order reaction. Therefore, the next reaction is third order reaction. In this properties of reaction order. The reaction orders cannot be deducted from the balanced chemical equation. Reaction order are usually positive integers or zero. Reaction order can be fractional or negative. And determine the reaction from the rate law. First one is the first problem. For each of the following reaction, determine the reaction order with respect to each reactant and overall reaction order from the given rate law. Firstly, the reaction of the mm, reaction of this problem, and the how many reactants are this the rate law. The solution, firstly there are three examples of the rate law. Firstly, inspect the law not be consequence and balance chemical reaction. First, the solution of these three reaction. The first reaction is second, or the reaction is second order in NO, and first order in O2 to give an overall reaction is third order reaction. Why? The 2 moles of the NO and 1 moles of the O2 to give the 3 moles. Therefore, this is the third order reaction. Okay, is it clear? Next reaction is the 3 by 2 orders in CH3CHO, and 3 by 2 orders is overall. Next is the reaction, last one reaction example is the reaction is first order in H2O2. This is the hydrogen peroxide in first order, and I minus is the zero order in H plus, and the second order is overall. First order and zero order, therefore the two overall reaction is second order reaction. Okay, determine the reaction order. Next, for example, is O2 plus twice NO to give twice NO2. The rate of reaction is K, concentration of O2 plus and concentration of the NO. To find and the M and pi, a series of experiment, the reactant conductance starting with different sets of reactant concentration. The initial reaction is measured in each experiment. Okay, the unit of the rate constant K for several overall reaction order. The units of this first order reaction, second order reaction, third order reaction. Firstly, step by step, the zero order reaction, the unit is moles per liter or moles per liter per second. First order reaction unit is moles per second or second inverse. Third is second order reaction is moles per liter per second. This is the second order reaction, and third order reaction is liter square per mole square and second inverse or second inverse. This is the unit of rate of constant. Next is the integrated rate law or change in concentration with reaction time. This is the last topic of this video. Consider a general or first order reaction. A changes to A to B. A is reactant and B is product. The rate of reaction is rate is equal to minus delta A divided by delta T is equal to K into concentration of A. Why concentration of A? Only reactant is 1 or first order reaction. Upon integration over time we obtain ln A0 for AT is equal to KT. Ln is the natural logarithm, A0 is the concentration of A at time T is equal to 0, and concentration of A at T, concentration of A at time is T. Ln of A0 minus ln of AT is equal to KT. This is the integrated rate law. The reaction order from the integrated rate law. Graphical methods to determine the reaction orders when you don't have initial rate data. Rearrange integrated rate laws. First order reaction, then the next is the simple second order reaction and zeros order reaction. This is the reaction order of the integrated rate law. Next one topic is the reaction of half-life. Just other way to express the speed of reaction is of the half. Okay, the half-life reaction is the define the time required for the reactant concentration to each one half of its initial value. For a first order reaction at fixed condition, T half is a constant independent of a reactant concentration. Half-life for zero and second order reactions are in difference. Okay, firstly, simple second order reaction, the T half is equal to 1 by K concentration of A0. The rate or the second order reaction rate is equal to concentration of K into A square. Second order reaction process, the half life increases. Second, the zeroth order reaction for the half-life, the T half is equal to concentration of reactant or concentration of A0 divided by 2K. The zero order reaction, the rate is equal to K. For zero order reaction, higher initial reaction concentration translates into the longer half-lives. Rate law is a general elementary steps for the and molecularity and rate law. This is the last topic for this chemical kinetics. The A is A to give the product. The reactant is only for the A and product to the molecularity is unimolecular, and rate law is equal to K into concentration of A, therefore reactant is A. Second elementary step, the 2A to give the product. The molecularity is the biomolecular, and rate law is equal to R is equal to K into concentration of the A square. Why A square? This is the elementary step or reactant is 2A. Therefore, different reactant A plus B to give the reaction reactant to product is the biomolecular molecularity, and the rate law is concentration rate is equal to K into concentration of A and concentration of B. This is the biomolecular reaction or second order reaction. And last is the 2A plus B to give the product. This is the thermomolecular, or this is the reaction having the third order reaction. The rate of reaction is equal to K concentration of A square into concentration of the B. This is the third order reaction in chemical kinetics. Thank you for the watching the video. Thank you.